Hi, my name is Sam. I'm a lecturer in exercise science, and welcome to the lab. So before we dive into the review of technologies that we use in exercise science, it is really important to just have a little bit of understanding and background as to what we do. So here we collect physiological variables such as heart rate, power output, and we also look at the use of oxygen when we're exercising and how much carbon dioxide we're producing. We also look at biomechanical data that looks at different forces and angle of motion when someone is running or cycling or doing any type of physical activity. So let's have a deeper look into a couple of the existing technologies that we use in exercise science and also have a look at a review of how we can improve them. So this is the structure that we are going to be running with today. First of all, we'll have a look at a review of existing use of technology that's in exercise science, and we'll identify a few pedagogical issues with using those said technologies. And we'll have a look at the trial of solutions to improve the technologies being used. And we're going to have a focus today on two specific pieces of technologies, and one is on just a broad overview of exercise science equipment, and the second one is looking at online group discussions. So let's have a look at first technology, exercise science equipment. Before I go into that, it is really important to just provide a little bit of background on exercise science. So exercise science is a new degree which only started in 2018. It comprises of 15 different study areas, but they're actually non-mutually exclusive. And it is expected that graduates can actually bring together each of these domains and apply to all aspects of exercise science practice. So in exercise science, one of the pedagogical issues that have been identified is that although there are different areas, it is expected that graduates are able to integrate knowledge and skills of these different areas into simultaneous practice. Although they are vastly different in the different areas and they are traditionally taught separately, the separation of these different domains does not actually mimic real life. In terms of health and fitness, we always have to be taking a holistic approach when prescribing exercise to someone who's healthy or who is diagnosed with a certain metabolic disease. And naturally, employers would be attracted to industry-ready graduates who are better prepared and able to amalgamate multiple areas of exercise science. And as we're well into the 21st century, learning in exercise science should move away from the traditional lecture-based environment, and also it should be well designed, carefully designed such that technology can positively support teaching and learning. So this is an example of the two different areas of exercise science which can be used in one specific movement that is running. So on the left here, we have the measurement of physiological variables, which include oxygen consumption and carbon dioxide output, and also the measurement of heart rate. While on the right over here, we have the measure of kinematics in biomechanics, which is looking at the movement and the joint angles as we are running on a treadmill. And this is based on a theory by Becker et al., known as redesigning learning space. And within this context, technology should be used to support digital collaborations and seamless crosstalk between users of key equipment in exercise science. Exercise science classes should also be designed using novel technology to simulate the industry and encourage cross-disciplinary problem solving. So what we're doing here is to combine knowledge and application in physiology and biomechanics. And to achieve that, students need to be able to combine different pieces of equipment. For example, the combination of metabolic cart, motion capture cameras, processing software, and also other relevant analysis and presentation software. And this can be seen in the following video. Here we can see that the physiological data is being picked up by the computer on the left, while the participant is running on a treadmill, breathing gases into the mouthpiece, and the markers are on his body. And while these sensors are picking up the markers on the body, and in real time we can see the movement on the screen. This model of combined technology and exercise science can also be easily applied into other types of exercise such as cycling. And here we have a happy student. Now let us look at technology number 2, online group discussions. To help foster collaborative work between students, I regularly use an online discussion group for students to discuss lab data and also to promote peer interactions. Within the SAMA framework, group discussions can help to enhance the process by which students can achieve outcomes more efficiently. Indeed, threaded conversations are easily tracked and followed, and communication can be made at convenient times. Within this context, the core of the task remains the same. It also creates a community by which can promote a sense of belonging for students. However, there are limitations to online group discussions as well. For example, students and teachers need specific logins and devices to access the discussion space, and interactions can be lost when there is insufficient engagement and activity is sporadic within the discussion space. Therefore, online group discussions meet pedagogical outcomes only for those who actively participate. Further, as discussion boards are ungraded, students may lack the incentive to participate, and the quality and effort taken to account for accuracies in answers may also be lacking. To bolster online group discussions, I will be using Google Docs and Slides to encourage student accountability while maintaining the essence of group work. This approach also allows the modification of the task and also coordination of the activities based on team contribution to encourage better quality work and scientifically sound contributions. Shared documents which are trackable can promote ownership, and students are more likely to be engaged if they feel actively involved in the shaping of the learning. And this will result in a variety of user-driven collaboration, communication, and content innovation and creation.